So I'm going to dive into Rhibs quite a bit today, but in addition to that, I'm going to talk about the importance of high-level structure in your app. So say like you write your app, each one of the features is written completely beautifully. You maintain all your tech debt constantly, you clean up everything, of course you are. But if you don't separate your features from one another, and I don't mean if you don't separate your presentation from your view logic or your business logic, if you don't separate your features from one another, then engineers are going to start bumping into each other, and that is going to be a tax on everything that you do. That kind of tax gets higher the more engineers you have on a product. And at Uber, we have a pretty good number of engineers on each product we're building. Not the most. I think we're not as big on the number of engineers per app as Facebook has, for example, but it's pretty high. So this is why we went and we built Rhibs. So you don't have to guess at what this means the entire presentation. It stands for Rudder Interactor Builder, but the words right now are not that important. What you need to know for now is that this is an architecture framework heavily premised on the existence of X, and this is a platform that we've built for both iOS and Android, Swift and Java. This is not to say, yeah, that's Swift. This is not to say that we are promoting code sharing. It's more like we build our applications to work the same for two platforms. Why do we not try and build them at least somewhat similarly with the same principles? So we built these frameworks for both platforms. When engineers build a feature on iOS and they plan out how they're going to do it, they can plan that out alongside their Android engineer, and they can think together, and you have two minds working on this problem, whereas before you had one. So far, we have shipped 3 production apps on Android and 3 production apps entirely on iOS, entirely built upon this framework. So I can actually talk about this without getting too theoretical. So let's start off by getting really concrete for a minute. Let's talk about the very first app that we built on top of Rhibs. This is the Writer app. When we rewrote this thing in 2016 on top of Rhibs, we shipped with just as many features, actually a little bit more, and we were able to launch it with half as many conditional branches and filter statements than the original implementation. Come a year on, the size of the code base has now doubled or tripled, and we still don't have a single class that's particularly large. Our crash free rate is 99.97, which is an order of magnitude better than it was before, and also just pretty good in an absolute sense. And our build times are interesting, but I'll talk about that more later. The maybe more interesting kind of second order metrics are that if you ask engineers that worked on this app, would they recommend this application the way that we built it to people outside the company? They're now more than double as likely to do that. And also we see double as many diffs per engineer per unit time with this new design. That's kind of silly actually to talk about because there's a lot of factors that go into it, but I still like to bring it up. Okay, so for those of you that just wandered in, maybe you're like, I don't know what talk to go to, I'm just gonna go to this one, I'm out of time, already 5 minutes have passed the clock. Maybe I've now convinced you that Rhibs are worth spending the next 30 minutes hearing about. And the way that I'm gonna talk about that is I'm gonna talk about how architecture affected us before Rhibs. I'm then going to talk about how and why we design Rhibs, and then go into some of the different tools. My favorite part of every talk on like big tooling projects or on new architectures is always the part where the presenter talks about what came before. Because that part of the talk like really motivates everything else. It also is way more honest than any talk about how something went well could possibly ever be. And it's also usually kind of funny, or at least embarrassing. And with that, let's segue into talking about how our app used to be. So this is actually our new app, but the product experience is kind of similar. If you look at this thing, you'll see that it really always had to be a single activity app. There are things that slide in and out over the map. We kind of like smoothly pan to different screens, and you cannot share the map between different activities. Even if you could, you wouldn't be able to do it very well, and it would be a pretty unpleasant experience. So we always built this as a single activity. What does that look like architecturally? Let's look at some boxes and some sticks. There we go, 1 box. Architecture done, we did it. Okay, we split this up a little bit more. We created a controller for each screen. And it's interesting to point out that these were actually written very well, right? Like these were testable controllers. A lot of them used something like MVP, and a few of them even used what you would now call MVI. They had reducers and everything. And they were broken down further. They had, custom views and custom controllers, or like subcontrollers. So what's the problem? I just said that this was great, right? Well, I mentioned that the different screens shared a map, but they shared other things too. Like, for example, one screen might have had the feed, and then you go to the next screen, and you still have the feed, but now it's locked in place at the bottom. Or more problematically, a lot of the screens had shared mutable state. So if you look at this sitter screen right here, so you can choose which product that you're going to take, like UberXL or SUV. And if you switch it from UberXL to SUV, and then you go to the next screen, now instead of saying this location refinement screen, you might see something that says, oh, you're in Amsterdam, and you checked the SUV box. Do you need towing capacity? Because maybe that's a thing that we have in Amsterdam. Or if you had pressed back, now you go to that home screen, instead of seeing cars that kind of look like weird future Priuses, you would now see a bunch of SUV icons. So if we look at our sticks and arrows again, you can imagine that now we're putting some state inside this logged-in activity. Let's say a behavior relay or something. You can try and avoid that. You could say, all right, maybe actually each one of these screens, it's like a step in a pipeline, and it outputs a very constrained output, and that output doesn't get elevated to a higher scope, it's just consumed by the next step. Except that actually all of these steps, they mutate that product selection. The home screen might have a promotion, and you could click on that promotion and then get switched into SUV. Also, the order of these steps is not set. The server could tell us to go from one screen to another at any time for whatever reason, and we have no recourse as mobile developers. So needless to say, there's now a behavior relay inside logged-in activity. There's also going to be some state, because sometimes there's some logic, because sometimes that state will be out of date. So we've got some resetting logic. If that logic depends on any other classes, then, well, we need the app to compile, so those classes also have to be inside logged-in activity, or within like its broader scope of existence. And of course, we also need navigation logic between the screens, so again, this goes inside logged-in activity. With all this said, this diagram is clearly dishonest. Let me update it. Okay. But it's still not that bad. And that's because there's only 3 screens. If you actually looked at our app and had tried it in the 80 other odd countries that we use our app in, you would realize that there are hundreds of screens in our app. I can't draw that many on this size of a keynote presenter. Yeah. So anyway, but I can put 5. I can draw 5, so we'll put 5 down. And you can imagine, wow, look at that keynote bug. Let's try it again. There we go. You can imagine that this is like a depth of 3, but has a width of like 100 wide. And if this happens, then logged-in activity is going to get bigger again. So what's so bad about this? Companies do this. It works. Right? I know this because I've talked to companies that are actually kind of big, and they built their applications as a set of distinct screens. Also, our Eats application is built kind of like this, and it works okay. So does that mean that the issues we were seeing were just because we were incompetent? I'm not going to say that's not true, because we're humble people, but I have some theories around this. One, if your application legitimately has a bunch of screens that are highly distinct, they don't share a lot of state, or the input and output from those screens is like highly constrained, then you're probably not going to see this problems with that. If the order of your different screens is highly set, again, you're probably not going to see very many problems, because the navigation logic that all gets munged into the top of your app is going to be pretty simple. But most importantly, architecture just does not matter if you do not have that many engineers. Right? If you could probably write your entire application inside a single method if you hated yourself, but you could probably do it. You could probably write it inside a single RX chain too, if you hate yourself a little bit less or more depending on your perspective. And that would work. You would be able to ship new features and you would be able to maintain them, though it might take a little bit longer, until you had 3 engineers, and then you would not be able to do it anymore. But even before you had 3 engineers, you would just start to see symptoms that something was wrong. And those are the kind of symptoms that we saw with a kind of decent architecture and a lot more engineers. And there was actually a bunch of symptoms. For example, we started to see consistency problems. we are trying to shoehorn this application with a bunch of screens that were kind of interlinked into this, okay, one like distinct screen states. And that required workarounds. Workarounds are by their nature something that not every engineer is going to do the same. So of course now our like application isn't entirely consistent. It's harder to understand. But we could have prevented that with really strong onboarding or like something cultural. What we couldn't have avoided is these two things here. This is inherent to the way that we were building our application. And I'm going to talk about the first one first, which is that we had these objects and this state information that stayed around longer than it needed to be, and therefore need to be aware of like other states and other classes in order to work properly. To illustrate this point, I'm going to have you look at a very, very silly class. And this class is called the driver is on their way toaster. And as you might imagine, the point of this class is to show a toast when the driver is on their way. So let's imagine we're building this thing. Okay, and that this class has to live inside logged activity for some reason, or within the lifespan of logged activity. So this thing lives when the driver is not on their way. So we need to wait until the driver is on their way. We subscribe to an RX stream, we wait for the driver to be on their way. Fine. Sometimes the driver goes on their way and then off their way, like they pause or something and then go back to being on their way again. And in that case, we do not want to show this again. So we create a little bit of state and make sure that we don't show it again in that case. Now I look at it, there's actually a bug, but whatever. Another condition is sometimes you'll have a driver that'll be on their way, and then they'll do the trip, and then they'll finish. The rider who has the app the whole time will be like, oh, I need to do another trip right now. So they'll go on the way again with a new driver, and this time we do need to show the toaster again, so we'll have to reset that bit of state. And if you want to write this class, you would make it work. Unlike me, you would have written a unit test, because I'm just writing it in Keynote. You would have written a unit test for it, you would have tested these various conditions, and you'd have launched it into production. It probably would have worked. Or maybe it wouldn't have, but the bug would have been kind of minor, like it would have only showed up every time that you had a single rider that took 2 trips while the app was in memory the whole time, and that's like a pretty small percentage, so you'd have been like, all right, I'll fix that in a couple weeks, and it wouldn't have been that bad in the meantime. But, oh, should I click that? But really, you shouldn't even need to worry about any of these things. You shouldn't even have to think, do I want to fix this bug or leave it for a month? You should just have to write show toast, because that's all that class is supposed to do. If this class only existed for the like length of time of a single driver, and it was created when that driver was first like created, and which is when they're going on their way, then all this class would be is showing a toast. You wouldn't have to think about the various like state transitions that went on while this class is alive, because none of those 3 transitions would exist. And this is like, actually I have a bunch of different examples I've seen of this. We can see in our old code base of where you have to like watch for state transitions, or where you have to make fields that are nullable and they really shouldn't have to be, all just because like this class is around longer than it needs to be. Okay. The other thing that we saw is that our app became a little bit hard to modify. So let's imagine that some PM asked me to produce a new feature, a great new feature, and we'll call it the new controller feature. And we'll put it in purple because it's being edited and it's new. If you want to integrate this thing into the app, of course you would also have to change the logged in activity. So we'll draw it as purple. Because anything you integrate has to be integrated with the logged in activity. And if we're going to change that, we have to change everything that's coupled with, which is everything. Because if you're going to change the logic inside the logged in activity, that's also going to affect the classes that lived within the lifespan, the scope of logged in activity, which is a lot of the things that are coupled to these different controllers here, and that are aware of the different states that exist, and that would have to be aware of this new state that exists for the new controller. So you either have to update all these things, or at the very least you have to test them, because you cannot be confident they work anymore. Okay, so at this point I think it's clear that there are problems that exist here, and at the very least it's worth investigating to see if we can solve some of them. How do we do that? Excellent question, imaginary audience member. I appreciate you asking that, because I was just about to answer it. In 2016, we decided that we are going to build a drastically different and better product experience for the Rider app. And we were also wanting a better engineering foundation. So we would do both of those at the same time. And if we were going to do this, we had better be damn certain that we had thought everything through. We were not going to half think something through in a rush and then rebuild the entire app on top of it. That'd be crazy. So a few engineers on Android and a few engineers on iOS got together and started trying out different architectural patterns, prototyping the Rider app on top of different architectural frameworks, modeling the application as a series of reactive pipes and just trying all sorts of crazy things, until we came upon some frameworks that we liked and some principles that we liked. At this point, we went and built the core of the application out with a few other engineers, and then for 3 months, hundreds of engineers just poured on and built the entire application on top of this framework. And this process slipped by 2 weeks, which is not that bad, and we learned a few things. One is that our original name for this framework was Rhiblets. That was terrible. It's now Ribs, which is much better. The other thing is that we had some usability issues, which we fixed, but the original principles held. And those principles, there was a few of them, but the most important ones are rephrasings of, those problems I said earlier. We need these not to be problems anymore. Like, for example, we need state to not live around longer than it needs to so that we can have more invariance and so we can have tighter, more explicit contracts. This problem is actually kind of hard to solve because we did have so many screens that shared state with one another. But not all screens shared state with each other. Some of them shared some shared more, and some shared less. And you could actually model this as a tree. You can imagine, if you look at this tree, that the nodes with more common ancestors shared like more common invariance or more state. And we decided that we would generalize this tree. We would call it a Rhib tree. And now the things here don't actually have to represent screens anymore. They're just nodes that have some business logic, some state, and sometimes a view. So this is pretty abstract. I know there's a lot of presentations that give you like boxes and sticks, and you're like, I understand that. But of course, no one does. So I'm going to try and illustrate this with an example. Imagine that you open the app for the first time, and you're logged in. So the root rib, which is off the top of the screen here, actually, attaches the logged in rib. The logged in rib says, OK, well, we're not on a trip yet, so I'm going to attach pre-trip. Pre-trip says, OK, well, we haven't done anything yet, so we're home. And home, so some shortcuts. You look at your device, you decide that you want to go home, you press the home button. At this point, the home rib gets torn down and the confirmation rib gets attached, but pre-trip is still there because it shares state between like home and confirmation from it. It has some of that state that gets shared. And you look at the app now and you think to yourself, damn, Asher on the Rider Experience screen team, he nailed this animation, he just killed it. But I do have to get home, so I press confirm. And then we tear down confirmation, we attach refinement. Refinement attaches location, location attaches favorites. Pre-trip is still there. You now futz around with the app a bit more. You say, okay, actually, I want to be on this side of the UCSF building, not this side. Okay, let's go. And now all of the left-hand side of the tree is gone. All that state is now just completely irrelevant and taken out of memory. And we have the on-trip side. Okay. So this idea looks pretty intuitive, I think. It's basically a hierarchical composition of controllers. What's novel is that we wanted this to work for an application with hundreds of nodes, and we wanted to make it convenient to have a deep hierarchy, right? We didn't want there to be 300 nodes, but all of them horizontal, because if that happens, where are you going to place the shared state? You're going to bubble it up into the single root node. You're not going to be able to break up the navigation logic, and also you're not going to be able to create like invariance inside each of the intermediary nodes. So we needed to make it easy to create this deep hierarchy. And there's a few issues to solve to make that possible. One is that it has to be really easy for a state to flow down the tree. When the on-trip rib is created, there's going to be a trip UUID. That's basically what defines if the trip rib gets created. And all of the ribs underneath that node in the tree, they need to get really easy access to that without going and updating constructors all over the place. So the way that we went about that was we decided that we are going to create a hierarchy of DI components, or on Android to be basically a bunch of data components or subcomponents. But wait, that sounds terrible, like really terrible. Are you telling me that we have an app with 300 data components in it? Yes. And that is because we do not make people write Dagger components. We just built an Intellij plugin, right? If you're going to create a Rhib, you would, this is the GitHub page for it. You would type sample OK, and then it would create the various Rhib constituent classes, and it would create your Dagger component and wire it up using various patterns. There'd be a couple to-dos, but it's mostly done for you, and you just attach it to your existing Rhib. But even with this, you could still create a hierarchy that's 300 wide and 2 deep. So there's another piece of the puzzle. Actually, certainly one big piece of the puzzle is that we need to have lots of good tutorials, and we need to educate engineers on best practices and reinforce those, which is incidentally why we've open sourced some of those tutorials that we use internally as a part of the GitHub repo. But there's also a technical piece of the puzzle. In order to answer that, I'm going to have to take a look at this Rhib class, and I'm going to have to bust it open for the first time. So here we have the different Rhib constituent classes. The interactor here is the one that does the business logic. You can imagine that means it's doing RX subscriptions, and it's telling its router which children Rhibs to attach and detach. Where the router is just a humble object. It does simple child attach detach operations. Nothing that really needs to be tested or that's too confusing. And by having that in a separate class, we're able to keep the interactor simpler. This is the interactor is where all the really complicated stuff happens, so we want to keep that by itself, keep it short, so that you can understand it and test it. But the really interesting thing on this slide is that view, which is optional. If you think back to the Rhib hierarchy, think about some of those intermediary nodes that I said I really liked a lot. A lot of them did not have anything visual on the screen. Right, the on-trip Rhib, there's nothing visual for being on trip, it's just a state. And also you could imagine that there's pretty often, you're going to have 2 Rhibs, they show up on the screen right beside each other, but they have very different lifespans, they don't share any state. Why should we be coerced into putting them close together on the Rhib tree? That would just lead to problems. So we make the view optional, and now you have the flexibility to have a separate, a different looking view hierarchy than Rhib hierarchy. I've said this before to people, and I don't think it makes sense until I show code, so I'll just do that. Okay. So here we have the root router. It's going to be told by its interactor that we should attach the logged in child Rhib. First step, we're going to build that child Rhib. We will explicitly pass the builder for that child Rhib an auth token, because that auth token will exist for the entire lifespan of the child, but not for the entire lifespan of us. For any other state that it wants, it can pull it directly from the DI graph. For any other state that the child wants from us, it can pass it directly from its DI graph, because all other state that it would want from us lives for our entire lifespan. After we build it, we attach it. That's pretty simple. And then we've got this extra step, which is that we have to attach its view. This is kind of different than most frameworks. It seems like a bit of a hassle that you have to do this separately, but it gives us a lot of flexibility. The downside, of course, is that if you forget to attach a view, then you will open up the app and nothing will be there. You'll be like, oh, I thought I was in the trip state, but I don't see anything. And that's fine. We just sort of linter, and now you can't forget. Okay, so we now have tree with a bunch of places to put shared state, so that that shared state can be scoped to a shorter period of time than the entire app, and a place to put invariants. But what about this open-closed principle? For those of you that do not like to think about what patterns jargon means, or can't remember this off the top of your head, it basically means that if you want your system to be maintainable in the long run, you have to be able to add features to it without modifying a bunch of existing code. So how do Rhibs help with that? Let's take a look at that root router again. But instead of looking at the implementation of any of the methods, let's just look at its interface. You'll notice that there are just attach and detach methods, nothing else. And this router, these routers in general, are what sits between an interactor and child Rhibs. So this means that the root interactor is not synchronously telling its children anything. Instead, we are communicating all state down this tree via Rx. So if you are the root Rhib and you want to communicate some location updates to all your children, whomever they may be, then you would create this location observable, you would put it on your dependency injection graph, and your children, if they care, would take it off their graph and then subscribe to it. Similarly, if we're communicating up the tree, we use listeners. And this is actually a super interesting, super important point. we do not use Rx to communicate up the graph. And the reason for that is if you use listeners for communicating up, you now do not have to subscribe and unsubscribe to any of your children ribs when you attach and detach them. You can take a child rib and you can bust it into like 5 different layers, and then the bottom layer can invoke that listener the same as before without having to like go and add a like Rx interface at every single level. You can have multiple children emitting the same listener. The parent doesn't need to care. Or you could even say, all right, the interactor says attach this child, and inside the router you could just delay it by 5 seconds, and literally none of the business logic in the app would change. Okay, so this means that we can like write ribs without needing to know very many details about our children at all, even though we have a compile time dependency on them. But what about the other way around? Does this mean that our children are super coupled to the parents? It's actually much less coupling in that direction. If you look at the tutorials that we've written, you'll see that the logged in rib in any of the tutorials do not have the word root anywhere in them. Not in a comment, not inside like a code reference. The word root is nowhere there. And that is because like the ribs, they only depend on a parent interface that their parent's DI component implements. So like the logged in builder, it defines this parent component interface. Inside this thing, you list all the dependencies you want. Or if you don't like listing a bunch of dependencies, you just type subcomponent.builder and then you get all of them for free. And then we build this ribs component by using that parent component as an input to it. Okay, so the rib primitives have some interesting properties around the ability to create invariants, reduce shared state, and what was it? Oh yeah, open close principle. But we don't build our apps on theoretical properties. It's more like what actually makes this work in the real world. I haven't even talked about a backstack. Do I have backstack support? Because you can't build an app without backstack. Come on, Brian, stop bullshitting me. Okay, so let me talk about 4 tools. I'll start by talking about backstack support. We don't have backstack support. Okay, we kind of do. The Rhib framework does not have strong opinions about backstack handling. Each Rhib gets to choose how to pass on backclick events to its children, but there are common patterns, and we decided to concretize, to build those patterns out as optional extensions to the Rhib framework. For example, screen stack is a super common one, which is to say that you want to attach a new Rhib as a child to yourself so it can access all your state, but you actually want it to show up on visually like it's a new activity. In that case, you would just push that Rhib onto the screen stack, and when the user presses back, that Rhib gets destroyed. What about deep linking? Deep linking is actually super hard in big apps. The no-thought approach to deep linking is inside a bunch of places in your app. Let's see, like near the root of your app, you would say, okay, I'm starting up. If the intent matches this pattern, attach logged in. And then somewhere inside like logged in, you would say, okay, if the intent matched this pattern, do this thing. And then somewhere else, like when you're on trip, you'd say, okay, if this intent matches this pattern, do this thing. And if you ever refactor your app, all of your deep links will break silently. And also, you are never going to be able to figure out the end-to-end flow for any of your deep links. So to solve this, we built something called workflows, or that we call workflows. And this is not to be confused with the thing that guy from Square built, but it's sort of similar. Which is that we go through the various ribs and we hook up reactive steps to each one of them. And then from those, we can chain all those steps together into in a single place that now expresses the entire end-to-end deep link, like actions that need to be taken. And this means that if you refactor your app and it breaks this chain, app will not compile. It also means you can see your deep link in one place. And because all these steps are reactive, this deep link, which basically kind of pulls you down through the Rhib tree to do various things, it could be done over the course of minutes, or it could be done over the course of hours or days. The first event, the first step might be wait until we're logged in. Obviously, if the user's already logged in, that's immediate, but it might take a while if they aren't. This next step might be let's wait until the user is on a trip, and it'll wait for them to go on a trip, and then let's wait until they open location editor, abort if they open the old version of the location editor, and then finally, the last step is show this nice sticker to thank them for installing our app via this link on the web, logging in, going on trip, and then using this feature. Yay. Yes, there's nice things there. Memory leaks. Pretty easy to leak memory in Android, especially if your app is like big and there's a lot of things with life cycles. Or especially if you use Rx, you have to remember to dispose all of your Rx chains. The way that we handle this is we use Rx life cycles, and then we use auto-dispose to bind all of our subscriptions to those Rx life cycles. But it's pretty easy to forget to do this, which is why we don't let you. We build a plugin to the error-prone compiler, and if you forget, the app won't compile. We built some other tools like that for like making sure that you null out references to routers and such, but this one's actually open source, so I'm highlighting it. Oh yeah, that's the thing you're not supposed to forget. Test code generation. At this point, I'm really just trying to like really express the point that it's tools that make frameworks like this practical. It's not about having high principles, that's important, but it's more about you get these principles, you try them for a while, and you realize that a ton of stuff is really hard to do. For example, like we use Dagger components, and setting up Dagger test components sucks. So we don't ask anyone to do it. Instead, we wrote this annotation processor that scans the setup of your Rhib and then generates a test component for you. Now let's go on to my final feature, my favorite feature. This one's actually not a tool at all, but I would call it a feature of Rhibs. And that's that basically every single Rhib depends on its parent via this parent component interface instead of having a direct dependency. So when you're building these things, you can just trivially go and put this thing inside its own module. Boom. And now if you imagine that you have a sufficiently powerful build system, let's say Buck, and you're using a language that is well supported by Buck, then you could decide that you're going to change a few of these modules. And if you change these modules in a way that did not break the ABI that their downstream consumer is dependent on, then you could recompile this entire app only recompiling those modules you changed, not the upstream ones, not the downstream ones. So in practical terms, what this means is that your app that used to take 6 minutes to do an incremental compile and Gradle is now going to recompile in 12 seconds. And this is a true number. I checked this yesterday on my laptop for a 40 megabyte app. We can recompile it in 12 seconds. And there's a bunch of other cool stuff you can do with Rhibs in terms of tooling and in terms of like module structure because of the parent component pattern. But there's no way I'm going to top that slide. So instead, I'm just going to finish out, and I'm going to ask something of you, which is that I want you all to go to this repo and star it. No, seriously, star the repo. I want stars. Give me stars. And then after though, not before, after you're done starring it, take a look at some of the tutorials, see if there are ideas there you like, or more practically, see if there are tools that you want to steal from us. Right? I know a bunch of different companies have built their own MVC frameworks. We have this like Intellij template that generates boilerplate for you, but you could easily steal that thing, not have to futz around with crazy Intellij APIs for a while, and then just convert it to generate your MVC framework for you. Or you could go and like steal our error-prone plugin that we use for ensuring that you don't forget to use autodispose, and that would just be, I don't know, I think that'd be cool. Okay, so I will answer questions now, but if we don't have time, or no, maybe we will actually, but if you come up with questions later, you can also just reach out to me on AST or the GitHub repo, or there's my email. No questions? Right, so the question was, the motivation for this framework was we had a single activity app with a whole bunch of shared state. What if you're in an application with a bunch of different like activities in it? Does it make sense to use? And my answer would be, it depends whether or not your different activities are something that share a lot of state, right? If you can build your application as a bunch of activities and they don't share much between them, then there's not a lot of motivation to do this. If they're sharing things that are inside, like in memory, or if they have shared views, then you might get a lot of benefit out of like actually building your application as a single activity application. You can like simplify your lifecycle tremendously by doing that, and in that case, it might be worthwhile. Yeah. How do we propagate state upwards? Is that the question? Okay. So you can imagine that there was like a root Rhib, and there was a logged in Rhib. Originally, when you install the app, there'll be a root Rhib, and there will be a logged out Rhib. And that logged out Rhib is going to do a ton of stuff. It'll do onboarding, whatever. But really, the only thing that root Rhib cares about is that the logged Rhib is going to pull a logged in listener from the root Rhib, and at some point it's going to emit on that listener that root Rhib has implemented to say, I'm logged in now. And that listener call is going to pass the logged in state with like an auth token back up to root rib. Root rib will then detach the logged in rib and attach a logged in one. So state up is via listener interfaces, yeah. Yeah, you use Rx to pass information down, listeners to pass information up. Yeah. Thanks for coming, everyone. And again, for star the repo. Star the repo.